Can you solve this math challenge? Here's the question. Given this equation 2 raised to y equals x squared equals 615, our goal is to solve for the values of x and y that satisfies this equation, provided that x and y are both integers. You can pause this video if you want to give this problem a try. And now, let's answer this question together. So, our goal in this question is to solve for the integer values of x and y that satisfies this equation 2 raised to y minus x squared equals 615. Now, before we start our solution, here is the final answer to this question. So we have two possible pairs of x and y. We have 59, 12, or x is negative 59, then y must be equal to 12. Now the question is, how do we get those values? And here's the solution. All right. So we have 2 raised to y minus x squared equals 615. Now take note of this. We have x squared. And if this 2 raised to y is a perfect square number, then we can use a difference of two squares. So difference of two squares states that if we have a squared minus b squared, this can be factored as follows: a minus b multiplied by a plus b. So we will force 2 raised to y to become a perfect square. To do that, we will do something like 2 raised to y raised to 1/2 raised to the power of 2. Now, 2 times 1 over 2, this is just 1, so this is simply equivalent to 2 raised to y. And now, y times 1 over 2, this can be written as y over 2. So now, 2 raised to y can be written as 2 raised to y over 2 raised to the power of 2. Now, this is now a perfect square. Therefore, we can now factor the left-hand side as follows. We have 2 raised to y over 2 minus x multiplied by 2 raised to y over 2 plus x. And now, let's focus on this number, the constant 615. Now, what we're going to do here is to get its factors. The reason is we are dealing with integer values of x and y. Now, 615 can be factored as 1 times 615, can be factored as 3 times 205, can be factored as 5 times 123, and can be factored as 15 times 41. So, we can say that 2 raised to y over 2 minus x can be equal to 1, and 2 raised to y over 2 plus x can be equal to 615, and so on and so forth. So to make this calculation more simple, let's make a table of some values. So 2 raised to y over 2 minus x can be 1, 3, 5, or 13. Also, 2 raised to y over 2 plus x can be 615, 205, 123, and 41, or vice versa. And now, what we're going to do is to add these two equations. And why we do that? Because take note, when we add these two equations, negative x and positive x cancel out. So this will give us 2 times 2 raised to y over 2 must be equal to 1 plus 615 will give us 616. 3 plus 205 is 208. 5 times 123 is 128. 15 plus 41 will give us 56. And now, we have a lot of factors of 2. So this is a multiple of 2, multiple of 2, multiple of 2, and a multiple of 2. So we can divide all of this number by 2. So this will give us 2 raised to the power of y over 2 must be equal to 313, 104, 64, and 28. Now, 313 cannot be written in 2 raised to some power. So this is not possible. 104 cannot be written again in 2 raised to some power. This is not possible also. And this 28 cannot be written also as 2 raised to some integer power. But 64 can be written as 2 raised to the power of 6. So we have only one possible case here. So 2 raised to y over 2 must be equal to 64. Again, 64 can be written as 2 raised to the power of 6. Now, since they are equal and the base are equal, so we can say that their exponent must be equal. So we can say that y over 2 must be equal to 6. Now, let's solve for the value of y. Let's multiply both sides by 2. So we have 6 times 2 will give us 12. So, the value of y must be equal to 12. Now, how about the value of x? Let's go back to our original equation. So we have 2 raised to y minus x squared equals to 615. We now know the value of y. This is equal to 12. So we can replace this y with 12. And 2 raised to 12 must be equal to 4096. Now, let's solve for the value of x. Let's add x squared on both sides, and let's subtract 615 on both sides. Now, 4096 minus 615, this will give us 3481. Now, we want to solve for the value of x, so let's get the square root on both sides. Now, we have two possible values here. We have positive or negative square root of 3481. The right-hand side, this is just x. But the question is, square root of 3481 is an integer? And yes, square root of 3481 is just 59. Therefore, when x equals to positive 59, y equals to 12. And when x is negative 59, y is also equal to 12. Therefore, we have two possible values here. So when x is 59, y must be 12. Or when x is negative 59, then y also equal to 12. And that is our answer. And as always, we are done.